Hi, everybody. We're almost done with the A section of IXL. This is about irrational versus rational numbers. And there's basically two ways to get an irrational number. One of them is to take the square root, of a non-perfect square. So, for example, the square root of 2, which is approximately 1.414, I think it's 926 and so on, keeps going forever and never repeats. So any multiple of the square root of 2, or like 3 times the square root of 2, would also be irrational. The other option for getting an irrational number is to look at something like this, where they add 9 to the square root of a non-perfect square. Now, the square root of 16 is not an irrational number because that is 4, which can be written as 4 over 1. Since this is a ratio, as is this is also. So that makes it a rational number. So in this case, 9 is rational. Let me get rid of that for a second. The square root of 17 plus 9 is irrational because that decimal continues forever, as does this one. And we'll submit. Now this time, we're multiplying 5 times 9, which is 45, over 1, 9 over 1, and 5 over 1. All of those are rational numbers. The square root of 27 is an irrational number. Remember that the square root of 25 is 5. This is a perfect square, and that is a rational number. The square root of 36 is 6 over 1. Any number between 25 and 36 that you take the square root of will give you an irrational number. So this one is a multiple. This one is irrational. And of course, this one is rational. Doing a little sorting here. Okay, now pi is also irrational. Pi is also considered to be a transcendental number. Pi, approximately 3.14. A lot of people think that's the exact value. It isn't. 3.14159.2. I think it's 59. Keeps going forever and ever and ever, never ends, never repeats. Obviously, this decimal will also not end and not repeat because it's going to be, if you add 1 and add 1, you're going to get 4.14159.2 and so on forever. It never ends and never repeats. So that one is irrational. This one, of course, is irrational, and 1 is 1 over 1. So there it is. Multiplying by a negative doesn't change anything. This one is also going to be irrational, irrational. And negative 2 is equal to negative 2 over 1. Remember, anything that can be written as a ratio is a rational number. Let's see. Multiplying by pi, and negative 3 is rational. Let's get this done. It's probably going to take a little while now. These are all just multiples. It's negative 10, 2, and negative 5. All of these can be put over 1, and they'll be ratios. Negative 8 is a ratio, negative 2, and negative 6. Square root of 40 is not a perfect square, so it's an irrational number. So is negative 2 times the square root of 40. Almost done. Square root of 44. 44 is not a perfect square. Negative 4 is rational. Pi pi is irrational, 10 plus pi is irrational, and pi is irrational. All of these, of course, basically one of the things they're kind of asking here is when they did addition on integers, you end up getting an integer. If you add two integers together, I just want to point this out, 5 plus -3, you end up with an integer. We say that addition is closed for integers, because if you add two integers together, you always get an integer. The same is true for multiplication. What is not true is division. For example, if I say 3 divided by 5, I get what's called a rational number, but it's not an integer. So we say that division is not closed for integers. All of these, of course, are rational. And pi is irrational, as is any multiple and any sum involving pi. The only exception is if you take pi and maybe subtract pi, which of course is an integer, and it's not irrational. By the way, 0 is rational. It's 0 over 1. More. Oh, more. All of these, of course, are rational. And we're done in under 5 minutes. Good job. Hope you got it. And we'll get this one done as well. Stop it.